So whenever you're designing a classification machine learning algorithm, a major challenge for you would be to how to evaluate that algorithm, especially if you have multiple alternative algorithms. The task is how to choose between them, how to decide which one is doing better than the other one. In this video, I'm going to talk about that, and towards that goal, I'm going to cover the concepts of confusion matrix. I'm going to talk about different types of errors, and most importantly, I'm going to talk about the three measures of performance, which are accuracy, recall, and precision. Let's start with an example. Suppose that you are given 5 pictures of cats and 5 pictures of dogs, and your task is to design a machine learning algorithm to correctly classify them. And this is the result of your algorithm. Some of them are correctly classified as cat, but some of them are incorrectly classified as dogs. So how can we have a formal measure, and how can we systematically look at the performance of this algorithm in this example? Well, that is done through a matrix that is called the confusion matrix, and it is a very simple 2x2 matrix. On one hand, on one side, you have the reality, right? Whether the animal is cat or not. And on the other hand, you have the classification, the labeling by the algorithm, whether the algorithm has classified something as a cat or not. Now, let's start filling this matrix. What does the first cell mean? And if you look closely, you see that this is the intersection of the animals that are actually cat and are also being labeled as a cat by the classification algorithm, right? So let's count how many there are. There are actually 3, right? So there is 1, 2, and 3 instances where a cat is correctly being labeled as a cat, and that would be 3. This is what is known commonly as true positive, right? The algorithm has correctly identified something to be a cat, and that is true, that is correct. How about the other part? How about the number of instances where the algorithm has identified a dog as a dog? In other words, identified something that is not a dog to be not a dog, right? And that would be 1, 2, 3, and 4, right? So there are 4 instances where a dog is correctly being classified as a dog. That would be called as true negative. In this particular example, it is correctly identified to not be a cat, right? That is why it's called true negative. Now, let's look at the instances where a cat is being incorrectly classified to not be a cat, right? And those are these 2 instances. In this particular one, the cat is pretty disappointed. So we put the number 2 here, and this is what we call false negative, right? The algorithm incorrectly classified something as not a cat, and that is false, right? And finally, the number of instances where the animal is not a cat, but is incorrectly being classified to be a cat is only 1, and this is what we call the false positive. In other words, the classification algorithm has falsely classified something that is not a cat under the group of cats, and that is false. All right, now that we have the confusion matrix discussed, we can go and talk about formal measures that we can evaluate the performance. And the very first one is accuracy. Simply put, accuracy measures the percentage of the times that the machine learning algorithm did a good job. In this case, it would be the number of true positives added with the true negatives divided by the total number of cases, and that would be 3 plus 4 divided by 10, which is 70%. In other words, in 70% of the instances, the machine learning algorithm did a good job of classifying. Now, there are even more interesting and exciting measures. The first one is recall. And the formula for that is true positives divided by true positives plus false negatives. And when you recall that this is the true positives, and this is the true true. This is the false negative, right? So that is 3 plus 2. And what is 3 plus 2? 3 plus 2 is 5, and it is the number of the cats that are out there, right? In other words, recall is answering this question of all the cats that are out there in reality in the data set, what percentage were you able to identify, right? So out of the total number of 5 cats, right, if you look at it, that is going to be the sum of the first row. Out of the total number of 5 cats, the algorithm was able to only classify 3 of them, right, or identify 3 of them. So it's 3 over 5, which is 60%. Now, the other measure is precision, and that would be true positives divided by the sum of true positives and false positives. Now, let's think a moment to understand what exactly it's asking. It's basically saying, of all the animals that you predicted to be cats, and you look at here, you see the classification cat. There are 3 here and 1 here. 3 of them are correct, 1 of them is incorrect, right? There are 4 instances where the algorithm has predicted the animal to be cat, right? Out of those 4 instances, only 3 instances are true. Only 3 instances are correct. In other words, of all the animals you predicted to be cats, only 75% were truly cats. That is what the precision is talking about. Now, let's move on from the example of cats and dog to a more practical example of investments. Suppose that among the S&P 500 stocks, the sample of 500 stocks out there, 5 golden stocks went to the moon. And for a moment, for simplicity, just let's assume that those were the stocks of Apple, American Express, Coca-Cola, Voyager Digital, and Google. Now, you want to choose between the 3 investors here. The first financial advisor is Jack Bogle. He is the founder of Vanguard, and it is telling you to go and buy the S&P 500 index, basically to go and buy all the 500 stocks. The other one is the legendary investor Warren Buffett, who's telling you to go and only buy Apple, American Express, and Coca-Cola. Finally, the last one is the Roaring Kitty. He is the guy behind the Wall Street bets who is advising you to go and YOLO all of your life savings on GME and AMC. Now, which one is a better financial investor? Which one should you follow the advice of? Let's start the comparison by creating the confusion matrix for each of them, right? So the first financial advisor, you can say that, okay, I'm going to create a confusion matrix. On one hand, I have the reality, right? The stocks that went to the moon and the stocks that didn't. And on the other side, you have the advice, buy or don't buy, right? The first guy told you to go and buy all the stocks. So because you bought all the stocks, 5 of them were also those that went to the moon. So out of the 5 stocks that went to the moon, he advised you to buy 5 of them, right? Out of the stocks that went to the moon, how many did he advise you to not buy? 0, because he actually told you to go buy everything. Now, out of the stocks that did not go to the moon, and we here, for the sake of simplicity, call them bad stocks, how many did he tell you to buy? 495, because he told you to go buy everything, right? And there were 495 out of 500 that were really not good stocks, and he told you to go buy all of them. That's why we have 495 here. And how many of the bad stocks did he tell you to not buy? Well, 0, because he told you to go buy everything, effectively not telling you to not buy any of the bad stocks, right? So this is the confusion matrix for Jack Bogle. How about the confusion matrix for Warren Buffett? Well, he told you to buy 3 stocks. All of those 3 were among the ones that went to the moon. So of the moon stocks, he told you to buy 3, but he failed to tell you to buy the other 2 ones, right? So in other words, by telling you that only buy Apple, American Express, and Coca-Cola, he told you to not buy Voyager and Google, right? So the 2 would be the value for this cell. How many of the bad stocks did he recommend to buy? Well, basically zero. He didn't recommend to buy any of the bad stocks. And how many of the bad stocks he told you to not buy? Effectively 495 of them, right? Because he only told you to buy 3 stocks and all 3 were good, none of them were bad, and he told you to don't buy any other stocks, of which 495 were actually bad stocks. And finally, the confusion matrix for Roaring Kitty would be 0 for true positives. 0 is basically the number of good stocks that he told you to buy, and the number of false negatives would be 5. What is false negative here? It is the stocks that he incorrectly told you to not buy, right? How many stocks did he told you to not buy? 498, right? Because he only told you to buy these 2 stocks. And out of those 498 that he told you to not buy, how many of them were incorrect? Well, 5 of them were incorrect because the rest were actually really bad stocks, right? But he also failed you by telling you to don't buy Apple, American Express, Coca-Cola, Voyager, and Google, right? So therefore, 5 is the value of false negatives. Now, for this cell, how many of the bad stocks did he tell you to buy? Well, 2, because GME and AMC in this particular example were considered to be bad stocks. So it's going to be 2. And then of the 495 bad stocks, he told you to not buy 493 of them. And that is the true negative, right? Now that we have created these confusion matrices, we can go and calculate the accuracy. Accuracy is what percentage of the stocks that was recommended to you were actually good. And that is basically the sum of the values on the diagonal divided by 500. This case, it would be 5 plus 0 divided by 500, in other words, 1%. For Warren Buffett, it would be 3 plus 495 divided by 500. This is 99.6, quite a high accuracy. And how about the Roaring Kitty? Roaring Kitty also gets a very high percentage of accuracy because it's 0 plus 493 divided by 500, 98.6. A neck-to-neck competition between Roaring Kitty and Mr. Buffett. And so is Roaring Kitty really that good? Is he that better than Warren Buffett, than Jack Bogle? Well, not so fast. Hold on. We can also calculate the concept of recall. And in this particular case, recall measures the percentage of all the golden stocks that the person advised you to buy, right? And it's very easy. If you remember the formula, it is true positives divided by true positives and false negatives. This is the true positive cell, and this is the false negative cell, right? And for all of them, it will end up to be 5. So for Jack Bogle, the true positives is 5 divided by true positives and false negative, which end up being 5, as I told you. So 5 over 5 is 100% recall, right? How about Warren Buffett? It's going to be 3 divided by 3 plus 2, which is 60%. And then the Roaring Kitty is going to be 0 divided by 0 plus 5, which is 0%. So when you consider the recall, you would see that Jack Bogle is actually doing much better than Roaring Kitty. And he is also doing better than Warren Buffett. Now, we can also calculate the concept of precision, which in this particular instance, it basically asks what percentage of your recommended stocks went to the moon, right? Out of the stocks that you recommended to me to buy, what percentage were actually going to the moon? And that is going to be the true positives divided by true positives and false positives, right? So basically, this is going to be this cell, the true positive, divided by the sum of the first column. For Jack Bogle, it is going to be 5 divided by 495. In other words, only 1% of the stocks that he recommended you to buy went to the moon, because it was actually 5 out of 500, right? That's 1%. How about Warren Buffett? Warren Buffett recommended you to buy 3 stocks. That's it. And all the 3 went to the moon. Therefore, the precision of Warren Buffett is 100%. Everything that he says goes to the moon, right? How about Roaring Kitty? he told you to buy, what percentage of the stocks that he told you to buy actually went to the moon? Zero, because it's zero divided by the total number of stocks that he recommended that you buy, which were 2, and that would be 0 divided by 2, which is 0%, right? So now this is a summary of the concepts of accuracy, recall, and precision, which would help you evaluate these 3 financial advisors. And depending on your situation, it's either Warren Buffett and or Jack Bogle that you would prefer. But in this case, other than recall, Warren Buffett is outperforming Jack Bogle. Now, in the context of machine learning, you can think of any of these 3 financial advisors as a machine learning algorithm for classification, and you can create these confusion matrix for the testing data set and calculate the measures of accuracy, recall, and precision for each of those different machine learning algorithms and see which one is performing better in all of these areas and choose accordingly amongst them.